Welcome to College Algebra. In this lecture video, we are going to continue our section 4.2 lecture video series. So in this video, I'm going to talk to you about synthetic divisions. What's considered as a synthetic division is a shortcut of long division. It is best to use synthetic division if the divisor has coefficient 1. So if you look at this example, the divisor has a leading coefficient 1 and the divisor is also raised into the first power. Now if the degree of the polynomial on the divisor is anything other than 1, then we will have to use the long division. So this is basically like a shortcut. Can I do long division here? Yes, I can, but synthetic division is just like a little shortcut, that can get where we can do our division quickly. Alright, so this is how it goes for the synthetic division. We will start out with an upside down division. In the inside, I'm going to write in the coefficient of my polynomial. Check for missing terms. 3, 2, 1, no power. So every term is listed. So 1x to the third, 3x squared, negative 14x, and negative 5. Alright, so these numbers, these are the coefficient of my polynomial. What do I use for divisor out here? Well, what we're going to do here is, for a moment, pretend my divisor will go into my polynomial evenly. What that means is I'm going to pretend my divisor is a factor. So if my x minus 3 is a factor to the polynomial, then I can set it equal to 0 and quickly find that x is equal to 3, which means 3 is one of my zeros to the polynomial. Okay. And ultimately what we're trying to do here is figure out how we can find the zeros. So for a moment, let's pretend x minus 3 is a factor, therefore 3 is a 0. So 3 will be my divisor I will use. So the first step, bring down the first coefficient. Second step, we will multiply. So 3 times 1 will be 3. And we put the 3 right below the second coefficient. Synthetic division is opposite of long division, so here we will add. So 3 plus 3 will be 6. So once I wrote my 6, we will multiply again. So we say 3 times 6, positive 18. Synthetic division, we will add to give me a positive 4. Multiply again, 3 times 4, positive 12. So negative 5 plus 12 will give me positive 7. Okay, so at the end of the problem, there's one more thing you need to consider. X to the third plus all these is divided by x to the first minus 3. So approximately, I am using x to the third divided by about x. So x to the third divided by x is about x squared. So what the synthetic division do is knock the exponent of the polynomial down 1 power at a time. So x going to x to the third about x squared times. So that means my first coefficient 1 is now 1x to the second power. The next term will be positive 6x to the second power. The following term got to be the constant term, which is positive 4. So that means the 7 will actually become my remainder to the problem. So we will write it as a quotient plus a remainder over the divisor, x minus 3. So that will be my answer. So now let's think about this. Well, my remainder is 7. That tells me that the x minus 3 does not go into the polynomial evenly. That means the x minus 3 is actually not a factor to the polynomial. So what we want ultimately is having 0 for remainder. If the remainder is 0, that tells me the divisor is a factor. My quotient is also a factor to the polynomial. So let's go back and take a look at the long division we done. The very first problem, we come find out the remainder is 0. So what that's saying was the 5x squared minus 3x minus 2 is a factor of this big polynomial. So is my quotient, the x to the third minus 2x squared plus 3x minus 4. This big old thing is also a factor of my polynomial. Alright. So let's check it out. Let's try another one. Alright, before we write it out, check for missing terms. So let me write my upside down division. My dividend. 5, 4, 3, 2, 1, then missing the constant term because the constant term is 0, x to the 0 power. Right? Anything to the 0 power is 1. 1 times 0 is 0. That's why this term is missing. But I still need it as a placeholder. So let's write in our coefficient here. 3, negative 19, 26, negative 26, negative 20, and let's make sure we put a 0 down here at the very end for the constant term. So for a moment, let us pretend that x minus 5 is a factor to this big old polynomial. Therefore, if I set my factor equal to 0, then x is equal to 5. So I'm pretending 5 is a 0 to my polynomial for right now. So I can go through the algorithm. So first step, bring down the 3. Second step, 5 times 3 is 15. Put below the second coefficient. Synthetic division, we will add. So negative 19 plus 15 will give me negative 4. Alright, let's multiply again. 5 times negative 4, negative 20. If I add, that will be 6. 5 times 6 is positive 30. If I add, that will be 4. And 5 times 4 will be positive 20. So if I add, that will be 0. And 5 times 0 is 0. If you add 0, you still get 0. So, just like the previous problem, the last number actually represents the remainder. So I actually have a 0 for remainder. And that tells me that 5 is a 0 to the polynomial. Therefore, x minus 5 will be a factor of this polynomial. Alright, so my first coefficient 3 now should be 3x to the 4th power. Because x go into x to the 5th about x to the 4th time, not the exponent down by 1. So my next term will be negative 4x to the 3rd, then plus 6x squared, then plus 4x. Okay, since my constant term is 0, I don't write anything. So this is my answer. Remaining 0. Alright, so this answer, because the remainder is 0, this quotient is also a factor to the polynomial. Alright, let's do another one real quick. This is a bigger one. Check for missing terms. 6, 5, ooh, missing a 4. It's missing because the coefficient is 0. So we will say 5, 30, 0, coefficient, -2, -12, 4, and 24. Alright, let's pretend x plus 6 is a factor of the polynomial. Therefore, if I set my factor equal to 0, my x will equal to -6. So let's pretend -6 is a 0 for a moment. Let's do the first step. Bring down the first coefficient. Then we multiply. -6 times 30, -30. Synthetic division, we will add. And now give me 0. -6 times 0 is 0. 0 plus 0 is 0. -6 times 0 is 0. Put below the -2. If I add, that's -2. -6 times -2, positive 12. If I add them, that will be 0. -6 times 0 is 0. Put below the 4. I add them, 4. So last step, -6 times 4, -24. So if I add them, my remainder will be 0 in this problem. So my answer, x going to x to the 6 about x to the 5 times. So my answer will be 5x to the 5th plus 0x to the 4th plus 0x to the 3rd minus 2x squared plus 0x plus 4. That will be my answer. Alrighty. And this is how we perform in synthetic division. Remember, the divisor, the degree of polynomial for your divisor got to be to the first power, okay, for the synthetic division to take place. Thank you for watching.